All right, hey guys, this is week 4 on the Science Activate questions, and week 4 here, we've got a small body of text, and we've got a nice big picture, and that's really all the information we've got. So that tells us that this is a data representation passage, and so what we want to do is we just want to ignore whatever's written here. We don't want to look at any of that, because we don't really need that. We can look at the graph and see what's going on. So let's look at the graph and just kind of tell what's going on. So we've got temperature on this graph. And we can tell that there are 3 different things. We've got one big one, and that is a 500 K. Whatever K is, we don't really need to know that. So this is a 500 line, this is the 400 line, and this one is the 300 line. And we've got some maximums here. We've got maximums, and you can go ahead and try to figure out what those maximums are right around there. There's a maximum here around 40 or a little bit higher, and this one's around 10. And so we've got those maximums. We've got those different lines. This is called a black body curve. Not really sure what black body means, but we can check that out. We've got a little bit down here. The wavelength is what's on our x-axis, and brightness is on our y-axis, so how bright something is. So black body may be something spacey. You can look up here. It doesn't say anything about space. But it's brightness and wavelength and stuff, so we can think about that. So let's look at the question here. Question number 1. The area under each blackbody curve gives a total amount of energy emitted every second by 1 meter squared of the blackbody. So which ranks those curves from greatest to least? Greatest to least according to total amount of energy emitted. So energy is under the curve. So if energy is under the curve, the bigger the curve is, the more energy there is. So we've got the 500 and then the 400 and then the 300. They all have different energies. So our better answer is with the 500 first. All these start with something that's smaller. So J is our answer. Let's look at number 2. Based on the figure, the temperature 300 K and wavelength of 30, the brightness is going to be what? So let's find the 300 K and a wavelength of 30. 30 is going to be way out here. So if we're looking at our brightness, it's going to be really small. It's going to be closer to 0 than anything else. So let's look at our answer choices. We've got less than 5 times 10 to the 6. That probably is correct. Let's look at this. This is between 5 and 40. That's not going to be it. Between 41 and 130, that's not it. Between greater than 130, that's not it. So A is our answer. Look at number 3. Number 3 says the radiation emitted by a star can be represented by the radiation from a black body. So this is about stars having the same temperature as the star's visible surface. So temperature-wise, as the visible surface, based on the figure, which black body curve best represents stars of equal diameter with surface temperatures. So we've got surface temperatures again, and we're looking at the radiation from a black body having the same temperature as the star's visible surface. So we had a black body curve over here that has everything. The highest one is the biggest curve, the medium one is the next curve, and the smallest is the smallest curve, and it starts on the left. So the only ones that start on the left are this one, and it starts with a 3,000 on the top. That's not it. This one's got 3,000 on the top. We're left with 9,000 and 9,000 here. And the only one that looks the same is J. So that one's our answer. Look at number 4. Based on the figure, the maximum of the black body curve will equal 75 times 10 to the 6 watts per meter cubed. 75 times 10 to the 6 watts per meter cubed when the temperature is closest to what? So we're looking at temperature. So we're going to find our temperature, and we're looking at our 75 watts per meter cubed. Well, that's our brightness answer over here. So where's 75 fall? 75 falls right in here. And so what curve might reach there? And if we were to graph this, it might look a little bit like that. And it's about halfway between 500 and 400, so that would be around 450, which is our best answer. Let's look at the last question. The frequency of radiation increases as the radiation's wavelength decreases. So as radiation increases, wavelength decreases. Based on this information, over all wavelengths in the figure, as the frequency increases, what happens to the brightness? So frequency increases also means wavelength decreases. And so if wavelength is going down, what's happening to the brightness? So let's look at our graph again. And as wavelength, this is our wavelength, as it goes down, so as it goes this way, our wavelength is going to decrease, and our brightness is going to increase, and then it decreases again. So brightness increases, then decreases, which means our answer is H. If you have any questions, let me know.